Hello and welcome back to our tutorial series on building a relational database with Golang. My name is Chris Franklin, and we're going to pick up where we left off from the first lesson, which is we have just built a successful REPL where we can run our application, and we can type in some basic commands, and it will give us suggestions on commands to enter. And so we can do something like .quit. Okay. So this is just a really bare bones REPL. We now have a way to start entering commands, and we have a way to start creating our actual database. But what we're going to build today is the very foundation of an actual database engine itself. Okay, we're doing this all within a REPL, but once you build these next pieces, you'll be able to use them from an embedded library, or you'll be able to use them from something like this command line REPL. And so that's what we're going to do. We're going to start building a couple of things that some of them will get thrown away eventually, but I want you to be able to see the basics of what is a SQL engine and how does it work. Okay, so let's get started. So we're going to start in the CLI package that we built last time, where we have our basic CLI engine using Go prompt, which is what's giving us the suggestions on what to actually type in. Okay. What we're going to do now is we're going to fill out this default block here in our executor. Okay, we're going to add in the ability to start handling some error cases and start giving some more useful commands. Okay, the first thing we're going to do is I'm going to add a new line here after here where we're going to handle, we only have two commands in the system right now, .quit and .exit. As I mentioned in the previous lesson, we're using the command structure very similar to SQLite, where a dot prefixes all commands. Okay, so what we can do now is we can say if strings dot has prefix. Okay, we've read the two commands that we recognize. We've now gotten to a point where we didn't recognize any of those. That means that anything that hits this point that is part of the string that starts with a dot means it's a command we don't actually recognize. So we have no idea what they're trying to do here. So what we can do is we can say log.error, and if you remember, we're using the zero log for actually pumping our messages out to command line. So we're going to put this together as a basic message, and inside the basic message, I'm going to use the fmt package to format a string. So we're going to use sprintf, which is how to print a formatted string to the command line, and we're going to do unrecognized command. We're going to do quotes, %s, and then in the little quote there, and then what we can do is comma, and we're going to pass in the command that we didn't recognize. So what this will allow us to do, now if we save this and we just run it, you'll be able to see if I do .tst, now we'll get an error message, unrecognized command .test. Okay, so anything that starts with a dot that we don't recognize, now we'll be able to handle that more gracefully and not just exit through as if everything was working. Okay, so this will case this is fine, but we also have to do one more thing here. We have to add a break. Just a break. Okay, the reason we do break is because we want to break out of the switch statement. If we hit this case, we don't want to continue processing. Now the next thing we're going to do is we're going to follow a basic structure, the architecture that SQLite follows. We're going to run through a prepare statement block, which is where we take the raw SQL command that's being passed in and we turn it into what's called a statement or a query. Okay, this is the actual machine code that represents what is trying to be executed by that SQL string that gets passed in. Then the second step is, once we've prepared that, we can then go in and actually execute that statement against our database. Now, we haven't written the database itself, and we haven't written any way to actually prepare these. So that's what we're going to start doing today. Okay. So we've passed this block. Now what we need to do is I'm going to write a couple of to-dos here so that we know what each of these are. The first thing we're going to do is prepare statement with SQL compiler. Okay, Now, I mentioned before, we're going to throw away some of this stuff. One of the things we're going to throw away is this compiler that we're writing here. This is going to be a really dead simple, bare bones compiler. The reason we're going to throw it away is because processing and tokenizing a large string like this is a ridiculous amount of work. In fact, it's so much work that it would be an entire tutorial series by itself. What I'm going to do today is I'm going to show you the basics of how to build this thing, and then we're going to be able to go and actually use a real, pretty simple SQL compiler to get some basic SQL commands that we can then turn into structs that we can use later on in our executor. Okay? But I want you to know that that's what we're going to do. So don't get super attached to this, because we are eventually going to throw it away. Okay, so we're going to create a statement, and we're going to create a response. Okay? This is the basics of how to build these. And then I'm going to bring in a compiler.prepare statement. Actually, so prepare statement, and I'm going to pass in the string here. Now, none of this is going to work because we haven't actually created any of these things. And then we're going to say if the response is equal to, and we're going to create a compiler.success. So that means we successfully compiled. And then we're going to say there's going to be another package that we're going to create. We're going to call it core. And we're going to put an execute statement inside of our database core. And we're going to pass in the prepared statement block. STAMNT. Yeah, what we just used above. And then we're going to have an else block where we're going to log an error. And we're going to pass in a new message. And we're going to say fmt.sprintf. And we're going to say unrecognized keyword at start of, and then we'll pass in the string that we failed to recognize, %s, and we'll pass in s. Okay? So this is everything that we're basically going to need. We're going to need to now create a compiler package and a core package to make all of this work. We could also add in eventually some new things into our suggestions. We can add some keywords that we can start with, things like that, and I'll show you how to do that in just a moment. But let's go ahead and get started with our basic compiler package. So I'm going to create a new package, and I'm going to call that the compiler. Now, as I said, we're going to delete this pretty soon, but for now, let's just go ahead and build it and see what things look like inside of it. Okay. Inside of this, I'm going to create something called a statement. So what a statement is let's declare this within our package, okay? And then I'm going to say type, and we're going to have a prepare result. And so that's what we were looking at before, is what was our actual processing, what did it look like? So we're going to say prepare result, and I'm going to call this an int 8. So there's only two cases that this could be. It's either going to be success or failure. And then here we can create our enum, just like we did in our last tutorial. So we're going to have success as one of our enum statements, and that's going to be a prepare result. And we're going to start with IOTA, okay? And then we're going to create a second constant, and we're going to say unrecognized statement, okay? So there we go. Now we have two values within our enum. One starts with success starts with 0, and unrecognized statement starts with 1. Okay. And then we need to declare what kind of statements are we actually going to be able to work with. So I'm going to create type, and I'm going to say type, and we're going to say int. Okay. So we're creating a type. We're going to call it type with a capital T, and we're going to call it, and it's going to be an integer. And now let's go ahead and declare this enum. And the two types that we're going to work with are insert, and this is going to be a type, and it's going to start also with IOTA. Okay. And then we're going to do a select. We're going to start with just two basic types. Okay. We can also do an error state. We could do that like down here, something like that. Okay. And then let's go ahead and create what our statement actually looks like. Now, this is our struct. This is what's going to hold everything. As I said, we're going to end up replacing this with a library that does all of this for us. But I want you to see what the internals of a library like this are actually going to start to look like, okay? So what is going to be inside of a statement? We're just going to start with a really basic type, and we're going to call it type, okay? So that's it. We have the field type, and it is of type internally here. And that means it's either going to be an insert or a select that's stored in this value. Okay, and then finally, I mentioned before we were going to do a prepare statement, and that prepare statement was going to have an input, which is going to be the actual statement that we want to prepare. And we're going to return a statement and a prepare result. Okay. So if strings, we're going to bring in strings, dot has prefix. So if our string, our input string, starts with insert. Okay. Remember, we turned everything to lowercase at above when we're actually processing this. So what comes in here should be lowercase, and it should match this if it's an insert. Then what we're going to do is we're going to return a new statement with an insert type, and then we're going to return success. Okay. Oops. And we need a comma here for this all to work. There we go. So there we go. That's what we're going to return if we recognize an insert. And then we're going to do an else if strings dot has prefix again on the input. And we'll do this one as a select. Okay. So this is the basics of how we start to process our statement, how to prepare it, how to do all of this. Now, it's going to turn a whole lot more complicated than this very quickly. But this is a really basic way of actually processing all of this. So we're going to set the type as select, and then we're going to return again a success. Okay. And finally, we're going to return a statement that has an error in it and unrecognized statement. Okay. So here we go. This is a really dead bone simple prepare statement, okay? As I mentioned, parsing and processing SQL is actually extremely complicated. If you look at the SQL spec, you'll know that you can have multiple starting keywords. So you can have inputs, inserts, updates, deletes, create tables. Like there's so many things that you can do with SQL. And all we're handling here are two very basic cases. Did we say insert or did we say select? Now, on the select, we have to know what fields are we selecting. We have to know what table are we selecting from. We have to know what conditions we're looking for. All of this starts to get really complicated really fast. And the way we represent that internally is with a finite state machine. Now, I'm not going to build the finite state machine from scratch here. Okay, that's extremely complicated and way outside of the scope of this tutorial series. We're going to use a pre-built finite state machine for representing all of this in another library, and I think we'll probably do that in the next lesson. But I just wanted you to be aware of that's why we're doing all of this. Okay? Now, the last thing we need to make all of this work, if you go back to engine.go, you can now see that we now have the ability, I can bring in this compiler, and here, our prepare statement, there we go. Now we can see compiler is being brought in up here, and we're using it, the prepare statement properly. Now, the last thing we have to build is our core. Now, this is not going to get replaced. This is actually what makes a relational database a relational database. So this is what we are going to be building. We're going to be focused on this part of everything. Oops. Let's not move stuff all over the place. Okay, so let's go ahead and create a new package. We're going to call this core. This is the core of our system. Okay, and inside of core, we're going to create a new file. And that file is going to be called execute.go. This is where we're going to define our execution block. Okay. So I'm going to call this package core, and I'm going to say function execute statement, and I'm going to bring in a statement, and this is going to come from compiler. Yep, compiler.statement. There we go. Right there. All right. Look at that. Looks great. There's nothing else that needs to happen here. The execute statement block is actually going to do all of the work for us. we're going to do a switch on statement.type, and we're going to, inside of here, say case compiler.insert. Okay, and then we'll do a log, and 0log.log, log.info.message, and we're just going to print a basic message. This is where we would do an insert. Okay, oh, insert, there we go. Okay, so we're going to see this is where we're going to do an insert, and then we'll set up a second case, and that second case is going to say compiler.select, and we'll do the same thing. I'm going to copy this entire line here, and I'm going to paste this in here. This is where we would do a select. There we go. And so that's it. That's the entire engine for us. So if I come up here to execute statement and I hit here, there we go. So now I've brought this in. You can now see I've brought in both packages. I've brought in compiler and core. Now if we run this, we should be in a pretty good place. Okay. So if I say insert, bam, then I'm going to say this is where we would do an insert. If I say select and I hit enter, oh, look at that. This is where we would do a select. If I say delete, unrecognized keyword at the start of delete. Okay, because we haven't programmed it to recognize that keyword yet, it's going to give us an error and say, I don't know what this keyword actually is. Okay, and if I do .test, if you remember, .test is an unrecognized command instead of an unrecognized keyword because it starts with a dot. Okay, so it looks like we have all the basics in place. The only thing left that we could really do here is add a new block into our suggestions. So let's go open it. Let's close the getting started. Let's open our suggestions.go right up here where we do our command suggestions, and let's create a new block here. We're going to call this block var keyword suggestions. Okay, and this is going to equal another prompt.suggest, and we'll set this slice up. Now what I'll do here is I'm going to copy these two lines above, and we're just going to replace the things that are inside of them since this is exactly the same. So we're going to say start with a select, and we're going to change the description to say something like select statement to read data from a table. Okay, and then we're going to replace the dot exit with insert, and we're going to say insert statement to add data to a table. Okay. And then up here inside of our constant, we're going to create a new keywords constant. And we're going to, down here inside of our suggestion map, we're going to add keywords, keyword suggestions. There we go. Now, if I run this now, let's exit this and restart it. Now if I type in, there you go. We have our now insert suggestion. We can hit tab and hit enter, and we can say this is where we would do an insert. Okay, that's it. That's the very bare bones basic of how to build an entire SQL engine. You have the ability to actually create a compiler, and your compiler is going to have a basic statement block that it's going to generate. This is our machine language code that we're generating when we process that string. And then we have a way of actually tokenizing and processing the string. Now this is a very simple tokenization, as I mentioned. We'll do something more complicated in the next lesson by using another library. But this is the basics of how you would get started doing something like this. Once you've done that, then you pass it into our core where we have our execution engine. We read what the type is, and then we take whatever's inside of that and we can start to process it and store it into our data storage format, whatever that ends up looking like in the end, which we'll be covering that in a much later lesson. So that's it for now. I hope you all learned a lot from this lesson. If you have any questions, please feel free to post them in the comment section down below. And I look forward to seeing you in the next lesson.